So the constraints that come with the space environment have direct impact on the design we propose. One major point is the selection of the materials that need to be compliant with these environments and strong enough and tough enough to endure this environment. So we are talking about the vibrations during the launch, the shocks. We are talking about the thermal fatigue of the equipment in orbit. We are talking about the radiation resistance and the shielding of some materials to protect the electronics. And we are talking about the chemistry of the materials themselves to be able to withstand attacks and such kind of erosions. So material selection is probably key to is not probably, is actually the key for a good product in space.
This is a tricky subject because it will depend on the antenna, but for example, for big reflectors or reflectarrays, thermal deformation will directly impact the radiation pattern of the antenna. This means that we plan to radiate in a given direction, and if the thermal elastic distortion is not mastered enough, during the orbit you will have some variation of temperature and so some variation of the direction of pointing of the antenna, and it can be a disaster because if you are looking at the side you have very low performances.
Yes, from the launcher we directly get some mechanical solicitations. So different launchers have different response profiles in terms of vibrations and shocks. So usually we try to design a product that will sustain the loads of all the launchers available on the market so that we do not get mission dependent and launcher dependent. But we have some cases where the accommodation in the launcher can be really important as well. For the CubeSat type of satellites, we often are mounted in a dispenser that will eject the satellites in orbit, and the dispenser acts as a protection against those mechanical solicitations, so we can get much lower levels for the CubeSat-like satellites and much higher levels when the satellites are mounted directly on the rocket itself. So the launcher has and the accommodation has a direct impact on it.
I would say that first we have a short list of selectable materials that can be interesting for RF performances, and in this list, which is quite short, I know, mechanical and thermal engineer can say, okay, you want to use this or this material, but don't forget that this material has some properties that can be interesting for the robustness of the antenna or this kind of stuff. So yeah, we are, I would say, the princess in this story, where we have a very short list and just do with that.
We need to do shopping in this list.